We're still in the Ainsa basin, and if you looked at our last video when we looked at what we interpret to be a confined channel fill, we're now at a place which is roughly within the same stratigraphic interval within the Murillo Formation that you've seen in the Ainsa basin, but we're standing at a location where we're mud dominated. So we're looking at a thick cliff of mud, but with some resistive beds in there that we can kind of talk about what we think about them. I'm joined again by Brennan here, and what we'll do here is we'll do a little scientific debate, arguing two different interpretations of at least a portion of this fine-grained material, and kind of see, you know, what you guys think of it. So according to the formal debate rules, I'll go first with my arguments, and then Brandon will do his arguments, and then I'll do a little sum up in the end to kind of hopefully provide a balanced view of both opinions. So we're here in a stack of fine-grained rocks. And where do we get fine-grained rocks in deep-water depositional systems that are confined? Because we were confined in the last outcrop. One of the most common places to get at is to build levees. So most of these confined systems are not actually erosionally confined, but they're constructionally confined by the buildup of the levees, the overflow of these turbidites. So I'm going to make an argument that we are looking at stacks of levee deposits here adjacent to channels. One of the most convincing arguments for that here is the geometry that we see. So one of the intervals that you'll hopefully see in Chris's frame goes kind of from this interval here, which is the ledge over on the far side, to kind of the overhang above me here. And you can see that that interval is rapidly thinning in that direction to less than ½ meter in total thickness, and it's probably about 4 or 5 meters thick over here. So that very rapid thinning and thickening is something that we see in levees. So to me it has the geometry of a levee. The other thing that we would expect to see in levees is mostly mud, which we have here, but with some fine sands in there as well. And we do see some beds in here that are coarser grains that I interpret to be kind of sandy overflow of very significant turbulent flows inside of there. So given that I know that we are in the confined system below here, I would expect that the mud in here would be mostly associated with levees. I think the geometry points to that. I think the overall net to gross in the presence of sands points to that. So I interpret these stacks of mud with thin sands to be levee deposits.
Okay, well, so although the geometries look a lot like levees, there are some observations that you would expect to find if you were looking to identify a levee. And while we do have that nice sand at the base that Rene pointed out, one thing we noticed when we measured the sections through here is that above that big fanning unit, it's almost entirely very fine grained. So it's sandy mudstone. In fact, it actually coarsens, it's mudstone at the base, but at the top it actually starts turning into more of a sandy mudstone. So it actually gets slightly coarser towards the top of the unit, which is kind of opposite of what you would expect for a levee. You'd expect it rather to go coarser grain at the base and then finer grained at the top as the levee builds out. Another thing that we might expect to see is as we go towards the thicker part of the levee, which in this case would be downstream, we might expect to run into a channel somewhere in which the levee is building along the side of. As this unit has been mapped around in the past, no such channel has really been observed. And the same thing, we go around further around the corner and further up the canyon, you really don't come into any channel form features in this unit. So those are kind of two strikes against the levee right there. Another thing that we do know is that this basin was probably fairly tectonically active. And so an alternative to the levee might be that we have some sedimentational growth associated with shifts in the basin accommodation. So you have some areas that are dropping and uplifting through time, allowing more accommodation in some places where we get this growth on lap geometry. And then even above, we can see that the beds are dipping in even slightly different directions. So we have a lot going on tectonically. So maybe the simpler explanation is that this is just compensating for changes in accommodation through time.
All right, so you've heard both sides of the argument, so I'll get a chance to summarize and provide the opinion. So when I first came to this outcrop 20 years ago with ExxonMobil, this was the Levee outcrop, because you know there's got to be levees in channelized systems, and wouldn't it be nice if we had an outcrop for that. So over the years I've kind of come back here and as you know, very much to Brandon's points, kind of thought about it a little bit harder. You know, Brandon's made some very fundamental basic observations on the lithology and stacking. So whatever you do, make those observations first before kind of what I did was maybe jump straight into the more arm wavy, this is what I would like it to be interpretation. So I think on the balance of the evidence, probably the weakest arguments for the levee is the stacking pattern within that unit doesn't quite fit. And as maybe a weaker but probably still a valid argument is that we really don't see any channel fills laterally associated with this stack of outcrops of finer grain deposits that we see here. So it probably isn't a levee, it's probably more of a system that is syntectonically depositing mud, and at times there are storms depositing these sands in a more random manner. So why do I care? That's always the most important part. Well, you care because if you're in a confined system, you see these stacks of mostly mud with thin sands. If it's a levee, it belongs to something bigger. Okay, so the levee belongs to a depositional system that is going to transport a lot of sand to the basin through confined systems. So it is lateral to that. And if you see levees in your core or in your well log, it gives you a much more predictive tool to say, okay, I should be expecting to find confined fills, and maybe if it's either not sand filled and it's bypass, find sand further down the basin. So the levees, that interpretation allows you to be a lot more predictive because it belongs to something. Whereas if it's just an overall muddy succession because maybe the sand was being kept further outboard because there was not a lot of sand being shed into the system, and I just get occasional storms, it's sort of a random, fairly low net to gross system that you can't really make much of a reservoir story out of it. So it's that it belongs to something. The analogy I sometimes use is if you were somewhere in the countryside and you saw just a bunch of small houses and farms, are you either on the edge of a city or are you just in, you know, farmland all the way through? You know, if you want to be in the city where the excitement, some kind of excitement happens, you look for those clues. It's like, do I see buses with signage towards cities? Do I see roads that kind of get busier in a certain direction? So it's the levee belongs to something that is a big depositional system, and if it's not that, then we're probably looking at an overall stack that is just overall finer grain with some more random sands in there. So, you know, what is it? I think the key here is make the observations. If you make the right observations, they'll stand the test of time, and you can always reinterpret them as you come back later. But if you have made the right observations on the outcrop, you can always bring back your notebook, and your perspectives are allowed to change. That's perfectly allowable in geology, on the outcrop as well as in the subsurface. So hopefully you enjoyed that little bit of debate, and let me know what you guys think this is.